An arithmetic sequence is a list of numbers with a common difference, and the common difference is just a number that is added to the previous number to get to the next one. So this sequence down here on the bottom left, 3, 5, 7, 9. What am I adding each time to get to the next one? That would be 2. That's my common difference. On the bottom right, what am I adding each time? Well, it looks like I'm subtracting, but if I'm going to put that in terms of what I'm adding each time, I am adding -4 each time. 20, 16, 12, 8, I'm adding -4 each time. We've got this explicit form that we're going to use. We've got a recursive form that we're going to use. So in your notes, if you would, just scribble down those blue terms. First term is going to be a sub 1, and d is the common difference. And on the right side of the recursive, a sub n minus 1 is just a real fancy way of some math person saying, hey, the previous term, and then plus d is the common difference. So that's just a really mathematical way of saying, hey, we're going to take this previous term and add this common difference to get to the next term. So if I've got 3, 8, 13, 18, ... that sequence is going to go on and on forever, just that list of numbers in that same adding that same difference each time. A sub 1 just means the first term. Please don't miss that on a test or a quiz. The common difference is what I'm adding each time. What I'm adding each time, that's just going to be 5. And the next thing I'm going to do is the explicit form. I've got that a sub 1 plus d times n minus 1. So I'm going to go ahead and write that. A sub n equals a sub 1 plus d times n minus 1. And that's a sub n on the left side. It's pretty bad handwriting. I'm just going to plug in what I've got. I've got a sub n equals, the first term is 3 plus the common difference is 5 times n minus 1. And sometimes people just leave it like that. That is a completely appropriate answer. Most of the time, they're going to distribute that 5 out. So do that and then combine all the like terms. So I think you'd get, what, 5n, and then -5 plus 3 would be -2. I think that's what that would be. And if I want to find this a sub 5 or a sub 10 or a sub 50, that's just a fancy way of saying, hey, let's find the 5th term, or let's find the 10th term, or the 50th term. I'm going to take that 5, that 5th term, and I'm going to plug it in for n on my explicit form. So a sub 5 equals, I'm going to take this up here and say 5, and where that n is, I'm going to plug in 5 right there, minus 2. And so the 5th term would be 25 minus 2 is 23. And now that was easy. If I had just asked you what's the 5th term, you would have said, well, it's 3 is the first, plus 5 is 8, that's a second, plus 5, 13, that's a third, that's the 4th, the 5th, well, I'm just going to add 5. That's 23, duh. But if it starts with a negative or some crazy decimal and you're adding some weird stuff, you can't really just necessarily tell what the 12th term or the 500th term is. So you good habit to get in is to get that explicit form and plug in whatever that is. Recursive. I've got a sub n equals a sub n minus 1 plus the common difference. And in this case, the common difference is 5. And then we usually write what you started with. So my first term was 3. Next one, first term is 4. Common difference. What am I doing each time? Well, it looks like I'm subtracting 3. So that means my common difference is -3. So if I'm writing my explicit form, that's a sub n equals a sub 1 plus the common difference times n minus 1. And you could have just written that as 4 minus 3 times n minus 1. I put the 2 signs there just so you can kind of see where that common difference is going to be at. Most time people will distribute that. That'd be a sub n equals, I think that would be -3n plus 3, so maybe plus 7. So more than likely, you're going to see that as a final answer. If you wanted to find the 8th term, a sub 8 would be -3, and then where that n is, you'd plug in 8. So -3 times 8 is -24. plus 7 is negative 17, I believe. The recursive form would be a sub n equals a sub n minus 1 plus the common difference, or in this case, minus 3, with a sub 1 being 4. Next one, I've got a sub 1 is 11. Common difference looks like you're subtracting 4 each time. So my explicit form would be a sub 1 plus the common difference. I'm just going to write minus 4 this time with n minus 1. And that means that I could distribute that to both of those. That would be negative 4n plus 4. So I think that's plus 15. And if I wanted to find the ninth term, I'm going to plug in 9 wherever that n is, right there, plus 15. So negative 4 times 9 is negative 36, and plus 15 I think is going to give you negative 21 would be the ninth term in that sequence. Recursive form, I've got a sub n equals a sub n minus 1. Remember, that's just a fancy way of saying the previous term plus the common difference, minus 4, and the first term is 11. You know, it's fairly easy when it's giving you a list, those first 4 terms or whatever, kind of plugging all that in. Sometimes you get a table like this where they skip values. So if I have a table that skips values, I have to use this slope formula. You know, you've probably seen the slope formula written like this, like y sub 2 minus y sub 1 over x2 minus x1, the row y's overrun. And same kind of ordeal. It's just kind of sequence notation here. A sub 2 minus a sub 1 over 2 minus 1. Something to take note of, though, is that, these numbers are consistent. They are the same each time. That is something that oftentimes helps students remember what to write on this slope formula. So find the common difference in the missing values. Well, I need to figure out what the common difference is first. So I could either take this set of numbers and this set of numbers, or I could use that 5 and 32. It does not really matter at all. I'm just going to use those 2 smaller numbers. So I would say this is a sub 3 minus a sub 1 over 3 minus 1. That's the third term minus the first term over 3 minus 1. That would be 18 minus 4 over 3 minus 1, and I think that is 7. So let's check it out. 4 plus 7 is 11, plus 7 is 18, plus 7 is 25, plus 7 is 32. That works out. The terms in a sequence increase by a constant amount. This is me telling you that this is going to be an arithmetic sequence if it's increasing by a constant amount each time. So the first term is 14, the fifth term is 42. This is the same thing as the last problem. You know, if I had a chart like I just had, and the first term was 14, and you come over here to the 2, 2, 3, 4, fifth term, dadgummit. Fifth term, rather. And the fifth term was 42. Same thing. You'll say 42, the fifth term, minus the first term over 5 minus 1. 42 minus 14 is 28 over 4. I think we got 7 again. So that's my common difference right there is 7. And my first term is 14. So those are the 2 things that I need when writing an explicit and a recursive form. So the explicit form is a sub n equals the first term plus the common difference times n minus 1. And I'm just going to distribute that. That's going to be 7n, and that's negative 7 plus 14 is plus 7. So there's your explicit form. If you want your recursive form, that would be a sub n equals a sub n minus 1 plus your common difference is 7, and your first term is 14. Same kind of ordeal right here. I'll probably just kind of give you a Cliff Notes version on this one. So, like, if you were to draw a chart, you got the second term right there is -3, and the third, fourth, fifth term is going to be -15. You're going to find the common difference first, and that's going to be -15 minus -3 over 5 minus 2. So -15 minus -3, that's like +3, so that's -12 over 5 minus 2. I think that's going to be -4. That's what we're doing each time. Let's see if that works. -4 would be -7, -4 would be -11, -4 would be -15. That one checks out. But when I'm writing my explicit and recursive form, I need the common difference and the first term. I have the second term and the fifth term. I guess I got all the terms now except for the first term. But if I'm subtracting 4 going this way, I need to add 4 going this way. So -3 plus 4 would be 1. That would be my first term. And then I could take 1 as my first term and -4 as my common difference and plug that in for my explicit and recursive. It says the following table represents a sequence. Fill in the table showing the first 5 terms. So if I've got 1, 2, 3, 4, 5, I'm just going to, if I want the first term, like this is my explicit formula. So if I want the first term, a sub 1 equals 1/2. I'm going to plug in 1. I'm going to plug in 2. I'm going to plug in 3. I'm going to plug in 4. I'm going to plug in 5 on each of those. On each of those. So for the first term, it's 1/2 times 1. That's 1/2 plus 3. If you punch that in your calculator, you probably get 3.5. If you were to plug in 2 right here, that would be 1/2 times 2. So that's like a sub 2 plus 3. I think that's going to give you 4. And if you were to plug in 3, that'd be 1/2, or a sub 3 equals 1/2 times 3 plus 3. I think that's going to give you 4.5, 5, and then 5.5. Lastly, I've got a recursive form, and I need to find the first 5 terms of the sequence. So it tells me that my first term is -5. And that top part tells me that every previous term, you'll add 4 to it to get the next term. So if I take -5 and add 4, that's -1. Add 4. +3. Add 4. That's 7. Add 4. That's 11.